Hello everyone. So in this video we are going to discuss a most frequently asked interview question. Even I faced this interview question a lot in my previous interviews that I have attended. So like the question is why Terraform becomes go very slow means sometimes Terraform apply itself takes more than 20 minutes, 25 minutes. This might initially takes 10 minutes, but gradually the time taken for this Terraform, even though we are trying to create the same resources each and every time, maybe you can consider in the different accounts or different environments. In some environments it took around 10 minutes, and some different whenever you applied on different day on different apply different account or environment, it is to take 15 minutes. So why these irregularities in the Terraform? So the reasons is I listed on the reasons here. It's mostly no one that much focus on this. Why? Because this interrupt provisioning is some one-time activity, but it is crucial when you want to update it. If you want to make some changes, any issue in the production, you are updating some change, you are modifying, suppose let us say in EKS clusters in the one of the node group, you updated the instance level from 5x large to more beyond that limit, you next level of that EC2 instance you have applied, that's immediate effect you need to get. So you try to perform Terraform apply, but it is taking lot of time, which means production is some impact is there. So before that we need to understand what is the reasons for this Terraform. So first thing is why Terraform is slow. It's not a Terraform fault, okay? It's not a issue from your Terraform. Then what could be the issue? Maybe cloud providers are slow, means when you are trying to create EKS, RDS, ALBs or VPCs, which means these are very high, more weight kind of resources or services in AWS. So generally it's taking minutes to provision, or either provision or delete such kind of resources. So Terraform is just waiting for AWS to finish, which means even though if you're trying to create these resources by logging to the AWS console or from AWS CLI, it would take good amount of time. Let us say for EKS cluster, I believe it's roughly taking 15 to 20 minutes at the minimum time that I am telling. Maybe in some cases it might reach to 30 or 35 minutes too. And the second important point is too many resources or dependencies. Means Terraform creates the resources in a order, sequential order. If you have very big infrastructure on the dependencies from one infrastructure, one resource to another resource, then generally it generally takes a lot of time to create all the resources. Which means, an example, if I tell, if you want to create suppose a node group on EKS cluster, the node group is associated with several security group. So it has to create the security group, and it has to link to the node group, and node group has to link to EKS cluster. So these are all the dependencies. The dependence might be implicit dependencies or explicit dependencies. The slowness observed in Terraform is because of this dependencies also. The same thing. Third one also, heavy dependencies. Unnecessarily depends on slow everything by forcing serial execution. So if you mention like explicit depends on if you are again and again or multiple times, or more depends on there in your code, it's forcing the serial execution. Means if though depends on block is not there or implicitly not mentioned, means implicitly or explicitly if it is not mentioned, Terraform can consider the creation of resources in the parallel manner. Okay, parallel execution can be possible, but if you mention the depends on, means it has to run everything in the sequential or serial manner. Next one, provisioners or null resources. Using remote eggs, local eggs means which is causing additional delays. Why? Because if you're trying to use this remote execution file provisioner, remote execution exec provisioner, it has to log into that particular resource, and it has to SSH, it has to deploy or run whatever the commands you mentioned. Like it generally takes a lot of time. Next, backend slowness. Even though the configuration of backend is at most required and locking also required, but it causes some delay when compared to maintaining backend in our local. But in general, in production, it's recommended to keep the our state file in the remote backend itself. Okay. Yeah, API throttling also the issue, means every AWS account that we are trying to connect, there are some API throttling limit is there. Like at a time, I have to accept 200 connections like that. In your organization, not only you, there are many people who is trying to connect to that particular AWS account from the different projects. Someone might try from console, someone try from AWS CLI, someone tries from this Terraform, or some other tries from CloudFormation, even others might try from the CDK. So it's all counts as a API request. Suppose the configuration for that account is API limit is 500. These multiple requests are again and again hitting, it may lead to the API throttling. That's also one of the reasons for the slowness of your Terraform code or Terraform execution. So destroy is always slower. Yeah, AWS takes a lot of time to clean up. It has to clean up in sequential order based on the dependencies. Even you try from the console also, it much takes a lot of time. So how to reduce Terraform execution time? Okay, split infra into multiple stacks. Keep slow stuff like VPC case separate, so you don't have to destroy or rebuild often. So if you keep these in the module structure, or you keep in a separate projects, means separate project in the sense one for VPC, one for VKS, instead of combining everything in one project. If you divide into the multiple project, that would be a bit quicker compared to the if you keep everything in a single project. I am saying that single project, not in the single file. Okay, increase parallelism. As I mentioned, you can increase the parallelism. 1 second, guys. One second, please. So increase parallelism. Terraform, I guess by default this is parallelism set to 10. We can increase the parallelism to 50 so that it can parallelly execute the resources all at a 50 resources or 50 parallel executions at a time. Okay, minimize the dependencies, means use fewer dependencies on, as I mentioned earlier in this point, if you try to keep the dependencies as less as possible, means implicit dependencies that can be taken care of the Terraform. I'm talking about the explicit dependencies. If you try to avoid the unnecessary dependencies, then there are chances that Terraform can take a bit faster, okay, for the execution. Avoid provisioners and null resources. If required, then try to, you have to use it. If it is not that much required, then you can better avoid those provisioners or null resources. This TerraGrunt, this is one of the advanced concepts. TerraGrunt is a kind of another layer or another tool on top of the base Terraform. Means it enhances to parallel runs even a bit more, and also caching capabilities also it has to, it's providing. Next is targeted apply, means instead of apply, means Terraform apply, I have not approve, instead of that you can apply particular blocks at the target particular resource. Okay, so what is the final takeaway of this post or this particular topic? Means Terraform isn't slow, your resources are. Basic thing is our Terraform project or Terraform code, nothing in the issue in the Terraform, but cloud provider itself is slow in this case. Okay, what are the resources that you are creating, based on that it will take. So optimize structure, parallelism and dependencies, and suddenly everything feels faster. Okay, we have to follow all the steps. I'll keep this post in the description. You can go through this image also for the quick reference. What are all the points we discussed here? It's also part of the particular image. Okay, thank you. So if someone is watching this video for the first time, please do consider to watch the other videos also in my channel. I basically make the videos mainly for the quick reference or for interview purpose, or to get the basic understanding of the concepts like DevOps or AWS Cloud or AI Ops, even ML Ops also. I'm planning to do all the videos. You can refer my videos that I started doing these videos from last 2 years, not very frequently. Yeah, on and off I used to do, but I'll try to make the videos from now onwards a bit very regularly. Yeah, please uh, try to watch other videos also. Thank you. Bye for now.